Kernel Exploits. What is a kernel? Kernels are the core of any operating system. Think of it as a layer between application software and the actual computer hardware. The kernel has complete control over the operating system, so exploiting a kernel vulnerability can result in execution as the root user. Finding and using kernel exploits is usually a simple process. You can enumerate the kernel version. A good way of doing that is the uname-a command. You can find matching exploits using Google, ExploitDB, or GitHub, and then usually you compile and run them. Beware though, as kernel exploits can often be unstable and may be one-shot or cause a system crash. I often recommend that when doing Linux privilege escalation, kernel exploits should be a last resort, i.e. you should explore every other avenue for privilege escalation before you try the kernel exploit. Let's enumerate the kernel version of the Debian VM using the uname command with the -a command line option. This reveals the kernel version as 2.6.32-5. On Kali, we can use the searchsploit tool to find matching exploits. We want specifically Linux kernel exploits, matching the version number we found, and we also only care about exploits that result in privilege escalation. We get a few results, but note that some do not exactly match the kernel version, or they refer to a specific distribution such as Ubuntu or CentOS. Let's try to adjust our search to be less specific with the kernel version, but more specific with the distribution. Again, we get a few results, but for various reasons, these will not work either. A better tool for finding relevant kernel exploits is the Linux Exploit Suggester 2. Let's run it and provide it with the kernel version. Right away, it tells us that this kernel is vulnerable to a popular kernel exploit called Dirty Cow. I've transferred the Dirty Cow exploit code over to the Debian VM. Let's view it. The exploit replaces the /user/bin/password executable with one that spawns a root shell. It contains compilation instructions, which we will copy and then run. There are no errors, but let's check that an exploit file was created. Good. Now let's run the exploit and wait. The exploit has completed. Let's execute the /user/bin/password file. We can verify that we get a root shell by using the id command. Remember to restore the original file when you are done.